properties of acids. It is mainly to do with reactions, so you pay attention. First one, acids react with reactive metals to form hydrogen gas and a salt. So when a metal reacts with an acid, the products are salt plus hydrogen gas. Example, magnesium ribbon. If you react magnesium ribbon with sulfuric acid, the products are magnesium sulfate and hydrogen gas. Now, to test for hydrogen gas, you will place a lighted splint at the end of the test tube, and if you hear a pop sound, that's an indication of hydrogen gas. So the test for hydrogen gas is called pop sound test. In line with the first chemical property of acids, we have two questions. First one, calcium, which is a reactive metal, calcium plus hydrochloric acid. We have learned that if acid reacts with a reactive metal, it will result in two products being produced. One would be a salt and hydrogen gas. So calcium reacting with hydrochloric acid, we have calcium, water would be calcium plus hydrogen ion and chloride ion. Chloride ion will go with calcium ion and will form calcium chloride, which is the salt, CaCl2, and hydrogen gas is one of the products. Second example, potassium solid with acid. Product, you will have hydrogen gas, which is one of the products, plus the salt. Potassium will go with sulfate, so your salt is potassium sulfate, K2SO4. Next chemical property, when an acid reacts with carbonate, it forms a salt, carbon dioxide, and water. First example, sodium carbonate. Sodium is metal with carbonate, it's a metal carbonate. React with hydrochloric acid will give you sodium chloride, water, and carbon dioxide, three products. To test for carbon dioxide, we know the name of the test is lime water test. You bubble the gas produced through lime water. It will turn milky. So if lime water turns milky, that's an indication that the gas produced is carbon dioxide. Let's look at some of the examples. First example, calcium carbonate is a metal carbonate, calcium metal carbonate plus hydrochloric acid. When a metal carbonate reacts with an acid, will give you three products. One would be gas, carbon dioxide, plus water and a salt. So calcium, ion, carbonate, ion. We have hydrogen plus ion from hydrochloric acid and chloride ion. So carbonate ion and hydrogen ion here results in water and carbon dioxide. Calcium will go with chlorine and will give you the salt calcium chloride, CaCl2. Potassium carbonate, which is a metal carbonate, plus the acid, sulfuric acid. Likewise, three products. You'll have your carbon dioxide, which is the gas produced, water, and your salt, potassium and sulfate will form the salt K2SO4 potassium sulfate. So any metal react with a metal carbonate. Don't forget three products: the salt, water. Because of metal carbonate, you have a gas, carbon dioxide. And the test for carbon dioxide is lime water test. When lime water turns milky, that's an indication that the gas produced is carbon dioxide. Third chemical property of acid. Acids react with metal oxides and hydroxide to produce salt and water. So acid with metal oxide, hydroxide product only two are salt and water. Metal oxide and acid, salt plus water product. Metal hydroxide,
salt and water.
Water. Examples? Calcium hydroxide plus hydrochloric acid. Calcium hydroxide is a metal hydroxide plus hydrochloric acid. We know will produce salt and waters, which are the products. Water is one of the products. Salt, calcium hydroxide and hydrochloric acid. Calcium hydroxide in water will produce calcium ion, hydroxide ion, hydrochloric acid, hydrogen ion plus chloride ion. Hydroxide and hydrogen results in the collection of in water will produce calcium ion and chloride gives you the calcium chloride CO2. Potassium hydroxide and sulfuric acid. Likewise, hydroxide ion with hydrogen will give you water. Potassium with sulfate will give you a salt K2SO4 potassium sulfate. So any metal hydroxide or any metal oxide when reacting with acid, two products, salt and water. Salt and water are produced now. Look at base. We don't have enough time. What is base? Base, like acid, base is any substance when dissolved in water produces hydroxide ion or increases hydroxide ion concentration. Common examples of bases, common bases: sodium oxide, zinc oxide, copper oxide, magnesium hydroxide, aluminium hydroxide. So most oxides and hydroxides are bases. The family of bases, there are two types. We have soluble bases and insoluble bases. Soluble bases, we know they are called alkalis. Insoluble bases are mostly metal oxides and hydroxides. Okay, definitions. Definition of an alkali. An alkali is a base that is soluble in water. All alkalis are bases, not all bases are alkalis. So some examples of alkalis: sodium hydroxide, potassium hydroxide. Any base that is in water is known as an alkali. Strength of base, similar to strength of acids. Strong base, like acid, strong base, they fully dissociate in water. Weak base, they partly dissociate in water. So any bases that fully dissociate or ionize fully in water is strong, partly is weak, similar to acid. concentration depends on the amount of water, and the solute ratio. More water, less solute is more dilute. More of the solute and less water is going to be more concentrated. So some examples of strong base, we have sodium hydroxide, sodium phosphate, barium hydroxide, calcium hydroxide. Weak bases, ammonia, potassium carbonate, sodium carbonate, those are weak bases. That means potassium carbonate in water partly dissociate to give to form to increase hydroxide ion. Questions? So at the end of the lesson, you should know how to define a base. So if I ask you when you come back, what is a base? You should define base as substance water produce or increase hydroxide ion concentration or hydroxide ion. What is the correct way to show hydroxide ion in solution? The correct way is hydroxide ion OH minus and aqueous in bracket. Explain the difference between strong base and weak base. A strong base is one that fully dissociates, and weak is one that partly dissociates to produce hydroxide ion. Okay. If you still can remember the property of acids in the first lesson, you can try and compare it with property of bases. So bases, first property of base, it tastes bitter. In acid, when we looked at acid property of an acid tastes sour. Base tastes bitter. An acid does not feel slippery or salty. Base feels slippery or salty. An acid, the pH value of an acid is less than 7. pH value of base is more than 7. 7 is neutral. Acid releases hydrogen ion concentration. Base releases hydroxide ion concentration. Okay, a base does not corrode metals. Acid corrodes metal. A base do not react with metal to produce a compound in hydrogen gas. An acid reacts with metal to produce compound and hydrogen ion. And a base turns litmus blue. Acid turns litmus red. So those are the properties of base. Chemical properties of alkalis. They react with acid to form salt and water, and this is known as a neutralization reaction. Some uses of bases or alkalis. Ammonia solution is used in window cleaning solutions. Calcium oxide is used to make iron concrete. Cement, magnesium hydroxide used in toothpaste to neutralize acid or teeth in anti-acid relief in digestion. Sodium hydroxide in making soap and detergent.
Taking time.
Okay. When an acid reacts with a base, the type of reaction is called neutralization. It is a double displacement reaction, but since it's to do with an acid and a base, it's specifically called neutralization reaction. So when an acid and a base react with each other, the characteristic properties of both are destroyed. This is called neutralization. The hydrogen ion concentration, hydroxide ion concentration neutralizes each other, so it results in a neutral solution. So it's called a neutralization reaction. One example of a neutralization reaction. A common example of a neutralization reaction occurs when you swallow an anti-acid tablet to relieve stomach upset. The acid in your stomach, which is hydrochloric acid, has a pH of 1.5 due to hydrochloric acid, and is produced by stomach lining. Anti-acid tablets contain a base such as sodium bicarbonate, magnesium hydroxide, or calcium carbonate, which are bases. The base will react with stomach acid, hydrochloric acid, and produce water. So it's a neutralization. That takes place. The reaction will lower the acidity and rises to pH to its normal value about 2. So pH value 2 is less acidic than 1.5. Okay, let's look at some neutralization reaction. Sodium hydroxide base plus hydrochloric acid. This is metal hydroxide and acid, so we'll give you a salt plus water. Sodium hydroxide is made up of sodium ion and hydroxide ion. Hydrochloric acid is hydrogen ion and chloride ion. So hydroxide plus hydrogen ion gives you water. Sodium plus chloride is the salt sodium chloride. Second example, aluminium hydroxide and sulfuric acid. You have aluminium ion, hydroxide ion, hydrogen ion, and sulfate ion. So hydroxide ion plus hydrogen ion here will result in water. Aluminium and sulfate, aluminium sulfate, formula Al2SO4. Okay, so before I go, the last question, reaction between hydrogen ion and hydroxide ion is called a neutralization. So when you maybe hopefully in our next lesson, we'll go through pH scale and I'll see you hopefully. Thank you.
Achoo!